Hello students. So today we are going to discuss some questions on the next concept of surface chemistry. That is, in previous classes we discussed about some questions regarding the adsorption concept, and today I am going to discuss some more questions on the next concept called as catalyst and colloids. So without wasting any time, we'll start with first question. So the first question is, which of the following types of metals make the most efficient catalyst? So options are alkali metals, transition metals, alkaline earth metals, radioactive elements. So the answer is transition elements, because in transition element where you can get S character as well as P character, and the most important thing is in transition element there will be a process called as breeding transition, where jumping of electron will take place from lower energy to higher energy, where they are more efficient in exchange of electrons. For that reason, or transfer of energy, for that reason, so option is transition metals. Next question. Sucrose, when made to react with water in presence of dilute H2SO4, is going to produce fructose and glucose. This reaction, dilute H2SO4, is called as, this was asked in AFMC exam. So dilute H2SO4 is called as homogeneous catalysis, option A. B, homogeneous, first one you can take it as heterogeneous catalysis. So two times that has been printed. Homogeneous catalysis, homogeneous. So first one option is homogeneous catalysis. Second option is homogeneous catalyst. C, heterogeneous catalysis, and D, heterogeneous catalyst. So catalysts are those which increases or decreases the rate of reaction. Catalysis is which involves the reaction which involves these catalysts are called as catalysis. So here all the reactant and the catalyst are in a same phase or liquid phase. So I will go with the answer called as homogeneous catalysis. Okay. For whole reaction, homogeneous catalysis. But here they have asked particularly about H2SO4. So where H2SO4 is going to act like a homogeneous catalyst. Okay. Homogeneous catalyst, same phase present in the reaction, is called as homogeneous catalysis. Next one. The decomposition of hydrogen peroxide H2O2 can be slowed by the addition of small amount of acetamide. The latter act as, one is detainer, stopper, promoter, and inhibitor. See, inhibitors are those compounds or the materials or the chemicals which are used in the process called as decomposition. So without thinking much, in decomposition process which we are going to use? Inhibitors. So the answer is inhibitor. Next question. A catalyst in a chemical reaction does not initiate a reaction, increases the activation energy of the reaction, of course, changes the equilibrium constant of a reaction, correct? Does not change the rate of reaction, no. So the answer will be does not initiate a reaction. A catalyst in a chemical reaction does not initiate the reaction, okay, but it increases the activation energy of the reaction, change in the equilibrium constant of the reaction, does not change the rate of reaction. So all the from B to D all options are correct, but the A option is does not initiate the reaction. So that means we can say, or we can consider like this: catalyst can do all these works from B to D, whatever the options are given, but it can't do this work, does not initiate the reaction. So I am going to remove this option. Next, addition of catalyst in a system increases equilibrium concentration. A. B. No effect on equilibrium concentration. C. Decreases equilibrium concentration. And D. Increases rate of forward reaction and decreases the rate of backward reaction. Of course, it increases rate of reaction, forward reaction as well as backward reaction. So the option is D. Next, A catalyst is used in a reaction to A. Change the nature of reaction and product, increase the reaction yield, decrease the need for the reaction, decrease the time required for the reaction. So the answer is decrease the time required for the reaction. The main purpose of the usage of these catalysts is to increase or decrease the rate of reaction. That is, to increase or decrease, in common way we can say, to increase or decrease the time that will be taken for the product, for the formation of the product. So that can be altered by the process called as by using a catalyst. So the option is decreases the time required for the reaction. Next, when KClO3 is heated, it decomposes into KCl, potassium chloride, and oxygen. If some MnO2, manganese oxide, is added, the reaction goes much faster because option A, MnO2 decomposes to give oxygen. No. Option B, MnO2 provides heat by the reacting. No. Better contact is provided by MnO2. No. MnO2 act as what? Catalyst. So the answer is MnO2 is acting like a catalyst. Next, platinized asbestos sheet. Platinized asbestos sheet is used as a catalyst in the manufacture of H2SO4, sulfuric acid. It is an example of heterogeneous catalyst, auto-catalyst, homogeneous catalyst, induced catalyst. So platinized asbestos sheet is a heterogeneous catalysis. Because H2SO4 is liquid, platinized asbestos sheet is a solid. So both the catalyst and the reactant are in different phase. So I will go with the word called as heterogeneous catalyst. Okay. Next question. A catalyst is a substance which alters the equilibrium in the reaction. B is always in the same phase as the reactant. C participates in the reaction and provides easier pathway for the same. D does not participate in the reaction but speed it up. So always remember, catalysts are those which increases or decreases the rate of reaction, but they are not involved in the reaction. So option is D. Does not participate in the reaction but speeds it up. In the reversible reaction, a catalyst is a substance which increases the rate of forward reaction, decreases the value of the enthalpy change in the reaction, reduces the time required for the reaction reaching the equilibrium state in the reaction, and D decreases the rate of reverse reaction. So you can consider this question as a homework. You try yourself. Okay, you try to find out the answer for this question. Okay. So, as I gave you some homework question, that is, in reversible reaction, a catalyst is the substance which, so the option is increases the rate of the forward reaction, decreases the value of enthalpy change in the reaction, reduces the time required for reaching the equilibrium state in the reaction, and option D is decreases the rate of reverse reaction. So the answer is option D. So it's not a D answer, so I forgot to mention, it is not C. I mean, it is not D option, it is C option. By mistake I told you D. See, in a reversible reaction, a catalyst is a substance which increases the rate of forward reaction, no, decreases the value of enthalpy change in the reaction, no, reduces the time required for the reaching the equilibrium state in the reaction. This is the answer. So by mistake I told you D. No, it is not D, it is C. Next one. In a homogeneous catalysis, the catalyst and the reactant should be gases. Yes, that is possible. The catalyst and the reactant should form a single phase. Yes, this can be an answer. A catalyst and the reactants are all solids. the catalyst and the reactions are all are liquids. All are solid, all are liquids is not a compulsory, they should be in the same phase. So I am going to going with the option called as B, the catalyst and the reactant should be formed single phase. Okay. So some more questions you can solve. So as we are going to give you assignment questions. So now this is all about catalyst. Two more questions I am going to add regarding enzymes which comes under catalyst only. Let me add those questions too. Okay. One second. So I'm just shifting my slide to the enzymes concept. Yes. 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 So the question is, let me zoom in. So the question is, the efficiency of an enzyme in catalyzing a reaction is due to its capacity to form enzyme substrate complex. That is correct. I mean, that is also possible to decrease the bond energy of the substance and the substrate molecule, to change the shape of the substrate molecule, to lower the activation energy of the reaction. So always remember, enzymes are also a biological catalyst. Their work is also to decrease or increase the rate of reaction by changing the activation energy. So I am going with the option called as to lower the activation energy of the reaction. Next, a biological catalyst is essentially an amino acid, carbohydrate, nitrogen molecule, and enzyme. So a biological catalyst is essentially an enzyme. So this is all about a concept called as catalyst and enzyme. Some more questions will be provided as an assignment to you students. You try to solve those questions, and whatever doubts you're going to get, you can ask us directly. Okay. So in the next class, I'm going to start with a next concept that is called as colloids. Yes. Today, we are going to discuss some more questions regarding the last concept of surface chemistry, that is called colloids. Okay? So let me begin with first question. Example of intrinsic colloids. Intrinsic colloids are those which can form readily whenever it is mixed with some other particles or the compounds which can form readily the colloidal particles. Those are called as intrinsic colloids. Okay? So example for intrinsic is glue, option A, B, sulfur, iron, and D is arsenic. So the option is arsenic because they are a good lyophilic and lyophobic colloids. They comes under protective colloids, whatever the colloidal list is there. So they comes under content of colloids called as protective colloids. So that's why, and they follow a rule called as Hardy-Screws rule, and they got a good flocculating value. So for that reason, they are the best example for intrinsic colloids. Now, which is not a colloid? Chlorophyll, egg, ruby glass, milk. So the option is chlorophyll. So because egg, ruby glass, and milk. So egg consists of protein is a colloid. Ruby glass is made up of carbon components, that is carbohydrate. So it is also a colloid. Milk is colloid. So chlorophyll is not a colloid. Which of the following forms a colloidal solution in water? NaCl, of course. Is it going to form? No. Glucose, of course, no. Starch, Yes, because it's a carbohydrate. Barium nitrate, no. So the option is starch. Which of the following does not contain hydrophobic structure? So where hydrophobic structure is nothing but which do not form components with the water, we can say. Linseed oil, lanolin, glycogen and rubber. So which of the following does not contain hydrophobic structure means rubber. Rubber does not contain hydrophobic structure. Leophobic colloids are leophobic and leophilic. Phobic means they do not mix properly. Phobic means they do not mix properly, so they don't have a proper structures. Okay. So leophobic colloids are reversible colloids, irreversible colloids, productive colloids, gum proteins. So they are irreversible colloids because they cannot mix properly. Difference between colloids and crystalloids is particle size. So no need to read the options. So how you going to differentiate colloids and crystalloids? Based on the particle size only by using microscope. So that's why particle composition, particle size, concentration, ion character. So I am going with particle size. Next. Size of colloidal particles varies from 1 nanometer to 1000 nanometers. So that is 10 raised to minus 7 to 10 raised to minus 9 meters. 10 raised to minus 9 to 10 raised to minus 17 meters, 10 raised to 5 minus 5 to 10 raised to 7 meters, 10 raised to 4 to 10 raised to 10 meters. So option E is 10 raised to minus 7 to 10 raised to minus 9 meters. Now, so let me consider some more questions for you guys. So some more questions I would like to solve. So these are the similar type of questions, same type of questions you're going to get right here, which you can solve as an assignment. Okay. So now, let me take some more questions, if possible. Which one should we can take? So these are the same questions with the repeated concept only. So there is no meaning in repeating the same concept every time. Same questions were given here. Some more questions I would like to solve. Let me go with some more question. Like I'm going to consider random questions. Like where it is. Yes. For example, there was a wonderful question which has been asked many times. It was there. Let me go with that question also. One more question I would like to solve here. So just give me some minute that I can get that question here. Yeah. Smoke is an example of gas dispersed in liquid. Once again, I will increase the size. Smoke is an example of gas dispersed in a liquid, gas dispersed in solid, solid dispersed in gas. So the option smoke is a solid that is dispersed in a gas. Now, milk is a colloid in which a liquid is dispersed in a liquid, a solid is dispersed in a liquid, a gas is dispersed in a liquid, some sugar is dispersed in a water. So the milk is what you are going to call emulsions. So emulsions are nothing but liquid dispersed in a liquid. So one more question was there. Let me check that question too. It's all about Ziegler-Natta catalyst that we use there. So I think I'm going to get that question here. Just give me 2 minutes time. I need to find that question. So while I was searching the questions, that time I got that question. So it was about Ziegler-Natta catalyst, TiCl4, whatever you're going to use. Okay, let me check that once. Okay, 1 minute. So that question was also there. So it was actually in the what you're going to call catalyst concept. So Ziegler-Natta catalysts are also used for the process. That was the question. So I was supposed to discuss that. I forgot to discuss. Wait, I will go to that question also. One second. Yeah, yes, this is a wonderful question. The component of Ziegler-Natta catalyst used in the polymerization of propylene are: first option PiCl3Al C2H5 thrice, PiCl4Al C2H5 thrice, Pi C2H5 thrice AlCl3, Ti C2H5 PiCl4 AlCl3. So the option is PiCl4 AlC2H5 thrice, which is a Ziegler-Natta catalyst, what we going to say. So the option is this one. So this is all about some questions regarding surface chemistry concept. So some more other questions are also there, so you can solve them as assignment questions. So in the next class I am going to start with the new topic. So thank you so much. I hope you understood the surface chemistry concept. If you got any doubts, you can ask me. Okay, anytime. You can ask me anytime. Okay, thank you so much. Thank you. This completes your surface chemistry CET NEET JE concept. Thank you.